Hello everyone. In this video, I'm going to walk you through how to do model selection in R. So I have loaded the basic stuff. So I have loaded the package. We are going to be using a data set from the ISLR2 package. We are going to use this data set called hitters that has information on some of the baseball players. We also need the leaps package to run the subset selection method. So make sure you have it installed before you load this library. So it is installed, ready to go. So the objective over here is to fit a predictive model for salary of the players. Okay, so the command to do best subset selection is reg subsets. I type in this command, open parenthesis, write the name of the variable that I want to predict. So this is going to be my dependent variable. Tilde dot means every other variable that is there in the data set is going to be counted as a potential predictor. So I'm going to run this line of code. The model is fit and we have some output over here. So let's take a look. So I'm not a baseball enthusiast, so I don't really have much idea about these numbers, but if I had to fit a one predictor model, so one predictor that best predicts salary, I would choose CRBI. That would be my choice for the best one predictor model. If I want to ramp it up and switch to a two variable model, I will still select CRBI denoted by the star, and I will add hits to it. And you can see that CRBI continues to be a choice for higher number of predictors in the model. But when I'm looking at a 7 predictor model, that CRBI is no longer the best choice, which means that there is some other combination of 7 predictors that does a better job of predicting salary, and that set of 7 predictors does not have CRBI in it. So that is what we have over here. So that is how we do best subset selection in R. We can also do a lot of other stuff. We also want to plot this and represent this diagrammatically. So we yes. So we can so over here we will look at the adjusted R square. So I'm going to this command will extract the adjusted R squares from the model. Make something found. Okay. So this model has these informations, which variable is the best set chosen, then the R square, RSS, adjusted R square, CP, BIC, outmat, and objective. So it does not have the AIC. So I can extract adjusted R square from here and I get these results. So these are the different adjusted R squares. And I want to plot them, so I run this block of code. Okay, I must have run the wrong model. So yeah, let's run this. Yes. So once I have all the models, I have extracted adjusted R squares. This which.max extracts that model with the highest adjusted R square. And this, if I run this line separately, it gives me 11. So the best model I can have in this data set is one with 11 predictors. And I can add a separate point over there, which is captured by this red dot. I can do the same exercise for malloc CP. So I plot the CP across all the number of variables. in this case, since this is MalloCP, I have to look at the minimum, figure out which one is the minimum, and then point it, highlight that in the graph, which again is, I think, the same number. No, so look at that. So if I'm looking at the adjusted R squared, I am coming up with an 11 predictor model. But if I'm looking at some other statistic like MalloCP, I am having my best model is a different one, which is 10 predictors. So depending on which criteria you're working with, you can get different results. If I look at the BIC, it's a different model. So if I use BIC as my criteria, then I have to work with a smaller predictive model. And this is consistent with what we know about BIC, because this measure is harsher and imposes a stricter penalty. So we have to work with a more simpler model if we use BIC as a criteria. And this is that. Next, we have the forward and the backward stepwise selection. The method is the same, rec subsets, but we add an argument in the function called method equals forward. Then we summarize, and for backward, we replace this forward with backward. Absolutely straightforward. You don't have to do anything by hand. There are packages and functions that let you do it. So you run these lines of code and you get the results. So see what's happening. So according to this model, this is the backwards. So let's run forward model. Yes. So as you can see, once CRBI is in the model, it will always stay in for all the higher order models. It won't get replaced eventually, because the way this algorithm works is once it's in, it will look for the next best predictor conditional on CRBI is already chosen. So that's how this method works. Simpler model, useful, has its pros as well as its cons. So it's up to you as a researcher when you're working with data to select which method to pick, which criteria to pick. So that is model selection in a subset. Nothing much fancy as far as the R codes are concerned. You just have to download the package, load it in the script, and just play around with different versions of this R rec subsets command. That's it.